Hello, and welcome to the next video in the mold design series. We will focus on the parting surface part feature of Cimatron mold design. This feature works hand in hand with the quick split function to establish the necessary parting surfaces to create our mold, core, and cavity parting surfaces. I'll be discussing creating internal, external surfaces, as well as runout and constructing corner locks. We're going to start with the part we split in the last video. I will choose a direction or a set of faces to create my parting line. Once we have established our part direction and have all the faces assigned, we will begin creating the parting line surfaces. It's not uncommon to use multiple sets of faces to do this. In cases with mechanisms, it's very necessary to use many sets. Here we will start with faces assigned to the core side and turn off all the other face sets. First, I will create the internal seal-offs. There are a few ways to do this. We can use many functions to make these individually. In Cimatron, however, we have a function that will create most, if not all, of these all at once. Since we are working with a closed solid, I'll use a cap internal islands function. We will need to select the area we would like the system to analyze for internal openings. In this case, we will select the entire part. There are a few options in this function. The system will show us all the islands it has found. I'll then apply these options and let the system develop the surfaces it can. The result is all the internal islands were capped, or filled in. I will now show the other faces to see how I'm progressing. Looking at the geometry, I've decided to use this horizontal feature to start developing our outside seal-off surfaces. I've determined earlier that this edge is consistent all along most of this part, so I will create a composite curve to help me develop my surface. Using the along open edge option, we can create this composite by selecting the first and last edge we want to follow. I'll select the edge starting just outside the U-shaped feature. Now I'm going to select the edge just before the side tab feature. Applying it, we have created a composite curve along these edges. I'll now create composite along the back and the other side of the part the same way. With these composites created, we can easily create our seal-off surfaces. Using some face tools, I'll use the extend surface from the part edge. Using the tangent option and telling the system the length we'd like, I'll develop a surface accordingly. We also have the option to create this surface as multiple faces or a single face. I'll create the other faces the same way. Now we'll look at the two areas on the sides. As I did with the other edges, I'll create a composite curve in these areas, selecting the first and last edge I want. We can now use the blend function by selecting the two edges of the extended faces. In this function, we can pick a boundary curve and have the blend surface follow it. We also have the option to make the two defining edges be tangent to the adjacent edges. This would create a much more tolerant surface. I'll now do the same with the other side. We can now look at developing the surface in this U-shaped feature. There are many face functions we could use to fill this area. There are many curved edges and contour changes here. First, we'll create a spline from the two extended faces to match the contour. We will then create another composite curve to make a boundary. I'm going to use this bounded face function. I'll now preview the result. You can see that we didn't get quite the result we'd like. Cimatron has a very useful function to develop surfaces in these areas. It's called warp faces. We can still use a composite curve with this warp face function. First, we'll have to create a face to warp. Using the sketcher feature, I'll make a sketch and a surface on the XY plane. I'm just going to create a flat surface. We'll now use the bounded function to make that surface. I chose the XY plane so the new surface is below the area I'd like to warp this surface up to. With the surface now, I can use the warp face function. First, I'll select the face to warp. And now select the boundary or composite that defines the area to fill in. We now have a much better surface in this area. It follows the contours much more smoothly and consistently. With all the seal-off areas addressed, we can now create the run-out surfaces. I'll make a new composite curve along the entire outside edge of the seal-off area. Using the extend function again, we can make a nice run-out surface. I'll give it a dimension to make sure I have sufficient surface to extend past the core and cavity block edges. I can come back and edit this later if need be. I've decided I like corner locks in this mold. I'll easily do this by adding a component to the assembly. By choosing the Add Duplicate Part from the Assembly feature, I'll select the corner locks I'd like to add. The corner lock component will also be added to the setup table, which we will discuss in another video, allowing me to control things like the spacing of the locks, as well as their length, height, and width. I will now just place these right on the main assembly UCS. Together with the quick split surfaces, I now have all I need to create the core and cavity blocks for this mold. This concludes the parting surface part portion of the mold design tools available from Cimatron. I hope you have found this informative, and look for our next video, Setup Table.